Calculus. Stationary points. Stationary points in calculus are basically maximum points on our graph, known as humps, or minimum points on our graph, known as troughs. So if we have an n-shaped graph, so that would be a minus x squared, we can see that we have a slope of 0 when the tangent touches the maximum point. And if we have a u-shaped graph, we can see that we have a slope of 0 when the tangent touches the minimum point. So, with a maximum point, as x increases, the gradient goes positive, then to 0, and then negative. So we can see that as x increases, so as x moves along our x-axis, moves along to the right, we can see that the gradient of a tangent to that curve would be positive, would have a positive slope. We can see that then when it touches off the maximum point, it would be a flat line, so it would have a slope of 0. And then we can see as it would continue past the maximum point, continuing on towards the positive part of the x-axis, it would then end up having a negative gradient, so a downhill slope. So we have a positive gradient, then we have a flat line, so we have no gradient, a slope of 0, and then we have a negative gradient. And it works the opposite way with minimum points. As x increases, the gradient goes negative, then to 0, and then positive. So it would start off as a negative slope, so a downhill slope as the x values increase. Then it would level off to a flat line or slope of 0, and then it would start to become a positive gradient. So, at a stationary point on a curve, so that is a maximum or a minimum, the gradient is going to be 0. So dy dx is going to be 0. The derivative will equal to 0. So, dy dx will equal to 0, and then d squared y dx squared will be less than 0 when we have a local maximum point. So the derivative will equal 0, and then the second derivative will be less than 0 when we have a local maximum point. And likewise, the derivative will equal 0, and the second derivative will be greater than 0 when we have a local minimum point. So second derivative less than 0 for local maximum point, second derivative greater than 0 for local minimum point.